Manufacturing has played an important role in society since the beginning of time. A strong manufacturing base leads to more research and development, innovation, productivity, and jobs. In the United States, manufacturing helps raise the living standards more than any other sector. Subtractive manufacturing processes, so mills, lathes, or any other process that builds parts by removing material from a stock piece, play a prominent role in manufacturing today. Tradesmen across the world in a variety of industries have relied on these machines to produce the parts that keep their plants running, making subtractive manufacturing one of the most prominent manufacturing technologies to date. Additive manufacturing technologies, on the other hand, are just starting to play a larger role in the global manufacturing landscape. For most people, additive manufacturing just recently became a household name. But in reality, the origin of 3D printing stems back almost 50 years into 1971 with the invention of modern-day inkjet technology. For 20 years after that, 3D printing isn't yet really a thing. It's more just the conception of modern-day 3D printing technologies, including stereolithography in 1984, fused deposition modeling in 1988, and selective laser sintering, also in 1988. After 1990, we start to see the world really adopt 3D printing for prototyping purposes. So we have a couple big names that are still around today, offer machines and materials, and we see computer-aided design have a more prominent role in the product development process. So in 1999, the first breakthrough 3D printing application is introduced to the world. Wake Forest's Institute of Regenerative Medicine 3D prints scaffolding and then builds a working bladder using a patient's cells around that 3D printed scaffolding. At this particular point in time, this is, for the world, the first time that we see the inherent benefits of 3D printing coming to realization. In 2004, Adrian Barr establishes the RepRap project, a project that was really centered around being able to make 3D printers with 3D printed components, so printers that could make more printers. And this opens up 3D printing to the masses. So now it's not just big companies with labs and R&D budgets that have access to 3D printing, but it's the common person. Educators, hobbyists, and that really does a lot for 3D printing in not only raising the exposure and understanding for how the technology works, but also the innovation and expanding on those capabilities. It wasn't until 2011 when the University of Southampton produced the world's first 3D printed UAV, and soon after CoreLogic introduces Irby, which is a concept vehicle with a completely 3D printed shell. 1 year later, in 2012, the National Accelerator for Additive Manufacturing, America Makes, is established in Youngstown, Ohio to accelerate the growth of 3D printing technologies across the nation. And over the next 7 years, we've seen a lot of companies come to the stage both to leverage the technologies and expand them for their own internal business capabilities, and also suppliers from machines, software, and material standpoint. In 2020, 3D printing once again had a chance to shine in delivering valuable protective equipment to healthcare workers and folks on the front line in response to COVID-19. So a lot of progress has been made on the 3D printing front. We have more machines that are available to market than ever before. We have more materials that are available to market, but we still have a lot of progress to make before we really make good on the promises and potential of 3D printing. So where do we go from here? 3D printing is still very much on the industrialization trajectory, in which case we're seeing slow growth for education for hobbyists, but we're still just hitting the tip of the iceberg for the high value commercial opportunities. The kind of opportunities that really leverage the inherent benefits of 3D printing, including design freedom, rapid manufacturing, and mass customization. How do we get there? Well, first and foremost, we have to approach some of the biggest technological challenges that still exist today, including a lack of materials for 3D printing, reliability of the equipment and materials, and also the ultimate value of 3D printing itself as it pertains to production environments. 3D printing is a technology that not only allows us to rapidly produce prototypes, but it's also something that allows us to further expand on business opportunities that have not existed in the past. It's not a technology that's going to overcome injection molding or casting, but it is something that allows us to tap into new business opportunities that have never existed before.